भाई कुछ ज्यादा ही बड़ा लंच कर रहे हो।
So, hello, my name is Gaurav. I work for Asan Jobs, and those of you who don't know Asan Jobs, let me give you a brief intro. We are a recruitment company. We try to connect between employer and partner and candidates. These are the main three stakeholders for us, and we have been in business for about 3 years. Fairly new startup, you can say that. Um, and today I'll be talking about front-end performance and security. The thing is, for a person who will talk about user expectations, uh, there's a mismatch between my expectation with this and your expectation. So basically, this will be fairly, bullet list of things to do rather than in-depth introduction of any of the parts. I believe that performance is a very big part of your application, and it essentially is a feature in itself. And if you agree with that or disagree with that, then we can talk about it. But if you consider performance as a crucial factor, these are things that you should focus on without going in depth in your code per se. But I'll tell you, okay, maybe look at this, look at this, look at this, and if you do all of this thing right, your user will have a better sense of performance, or better, they will perceive that your application loads faster. So first of all, anyways we should look for performance optimization. And before going to performance optimization, please understand there is a significant difference between the actual time that is spent and the perceived time. And all of your ideas behind performance optimization comes from this concept alone. That even though sometimes the actual time that is spent doing some action is larger, you can make your application perceive user in such a way that user feels that results are loading faster or your application is doing that action faster. So today we'll talk about why do time and performance matter, and why don't we like to wait, and why does faster not always mean better in the online world. Um, so let's delve into this before. So performance optimization, by the definition, it is the process of improving the delivery speed of services, feedback, or any other type of response action in order to meet the user's expectation. And the crucial word here is expectation. So if your user expects something to happen in 2 seconds, and if you take 10 seconds, no problem. If your user expects something to take 5 seconds, and if you deliver in 2 seconds, that's also a problem. For example, many of you, when you go to ClearGrip or any booking website, you see there's a huge time difference between your search and actual results shown. That most of the time, that time difference is put in just because it lets you feel that okay, this search engine is optimizing or trying to find the best price for you. Yeah, are you saying that's actually artificially put in? Yes. Yes. On the front end or on the back end? It can be anyways. But yeah, that's actually artificially put in. And for example, if you want to transfer some money from a bank account, if it happens instantaneously, I would be happy. Maybe you would be, but a large majority of users will not be. So basically, the point is for some action, user feels that okay, this is the appropriate time. Taking time is happening, I guess. So that's the crucial part, expectation. Okay. So there is a actually from psychology point of view, there has been quite a study that what is what is good action time first. So in psychology, people divide the action time in four categories. The first is instant, which is 0.11 to 0.2 second. This is the range of maximum acceptable response time to this to similar instantaneous behavior. So effectively, your brain even doesn't recognize that there is a delay when any action happens between this interval. Then 0.5 to 1 second. This is maximum response time for immediate behavior. So this is a response time your brain looks for when you are talking to somebody. For example, when I ask a person question and if he responds within zero point 0.5 to 1 second, that is immediate enough for me. So yeah, by application design, this should be the time frame where a click should happen, or a user should get a feedback that okay, click has happened. If you translate this to interfaces, then 2 to 5 seconds. This is the flow or optimal experience as a state when people experience concentration, absolute absorption in the activity. So basically, this is the time frame where people get involved in your action. So searching something or so this is the ideal time frame. So if your website or search results load anything between 2 to 5 seconds, that's ideal. And 5 to 10 seconds, the user would still be focused if their task is very important to them, but they can easily become distracted. So your user already always has a budget in his mind. Maybe he's traveling or he's doing some other task parallelly. He has a budget, especially with mobile growth. He has a budget of time that he has in his mind made up for your service. That okay, I'll do this for 5 minutes or two minutes and then leave kind of thing. So the better perception you have of your action happening, better feeling you will get for doing something in your website on your website. And 10 seconds is the absolute maximum time for a user's attention span. So if your action is taking anything more than 10 seconds, that's not good for your user and ultimately for you. So once we have understood that, let's go into 20% rule and a little bit of theory first. So in 1834, Weber postulated that he defined just noticeable difference as the minimum difference between a stimulation and that a person can detect most of the time. And since then, there has been a lot of research in what animals perceive, animals or humans perceive. What is that noticeable time difference? And then there was this student of his, Fechner, who applied this law for the measurement of sensations, and basically which set the basics of science of psychophysics. And this essentially tells us, ultimately it boiled down to Weber-Fechner law, and this essentially tells us that time intervals are prone to just noticeable time difference between 7% to 18% on average for shorter periods. And without going too much into the theory part, just if you understand this part that okay, the noticeable time difference is 20%. That's a good rule of thumb for any action when you're trying to optimize something. So I'll go into examples for this, but ultimately what is happening, in order for you users to barely see a time difference, it has to be changed at least by 20%. Okay, so let's look at few implementation parts. So let's say you have a search result page which currently takes about 5 seconds, and you did some performance optimization, and it went from 5.0 seconds to 4.5 seconds. For your user, it will not feel any difference because the total time difference is less than 20%. So उसके लिए वही search result page है. It will not feel any noticeable time difference. But if you're able to optimize to 4 seconds, that's a 20% difference. Then the user will feel okay, something has changed. My website has become faster. So this is very common when you as a front-end developer or other developer, we optimize something and we tell our managers or even CEO that okay, we have optimized this page, and they say, oh, I don't feel any change. This is the rule which goes there. Okay, when will they feel something is optimized or something is faster? That's the 20% part. This will also allow for regression allowance. So let's say you have changed the algorithm for your search result page, and because of that new feature, your search page has become slower. As long as it's not slower by 20%, your user will not mind from the previous iteration. So that is something called regression allowance. So it basically allows your code to be a bit slower without harming the user experience. But so this is your feature set. But let's say your search result page is currently serving search results at 5 seconds, but a new competitor comes into the market and he's serving page at 2 seconds. Then what do you do? Then what is this part is called effectively neutralization, where you are trying to catch up to a leader. Um, as I said, let's say your competitor is serving that same result at 2 seconds. So of course, from going from 5 seconds to 2 seconds is not an easy task. अगर वो इतना easy होता तो शायद you would have done it already. So what does theory tells us? One thing is 20% rule. If we go by 20% rule, then uh, if you cannot achieve 2 seconds, then 2.4 seconds is probably also out of reach just by going to 2.4, sorry, 20% rule. So that's the case. So so rule of regression always tells us that 2.4 seconds is the time we should look for. Uh, but as I said, it's not easy. So, but thankfully, there exists a magical psychological threshold, and time duration longer than this threshold will be perceived by the user being closer to the 5 second, whereas time duration less than this threshold will be perceived as closer to 2 seconds, and that threshold comes out to be the geometric mean rather than average mean, arithmetical mean, effectively. Um, so essentially, 3.2 second is that magical number which you are looking at. So if your competitor is serving the same page at 5 seconds and you are serving as 2 seconds, right? Sorry, my bad. If your competitor is serving as 2 seconds and you are serving as 5 seconds, if you are able to get your page to 3.2 seconds, your user will not feel much difference. He will feel that difference, but then the quality of results and other factors of the product starts coming into the picture. So that is a magical number where you should look for when you're analyzing your product from a competitor point of view. So yeah, as I said, performance is all about perception, and one of the things that you can do is start doing preemptive start. And newer browsers have very good support for all of these. So let's say if you want to pre-resolve the domain name that you will be using, use DNS prefetch to enable your browsers to fetch the DNS names beforehand. You can also pre-connect. This hint is used only to pre-resolve a domain name, not only to pre-resolve a domain name, but to initiate the full connection also. If you need some resources beforehand, what you can do is you can prefetch them. This hint has the lowest priority, and you can use it to prefetch assets or resources required for future navigation. So let's say you are serving a navigation, login page, and after doing the login, this is very true for nowadays. We have a huge one single page applications powered by React or Angular, and those libraries are very huge. So when you are serving the login page itself, you can start prefetching your resources which you will be needing in the next page. And then pre-render is also available, which is a very it's like a sword. You can cut yourself also, but it's a very useful thing. If you know that next page will have to be rendered, for example, checkout steps, then you can pre-render them. It will of course, browser will spend CPU time and network to pre-render that page, so you have to do it very judiciously. But yeah, that option is also available. Next part is, since we are talking about perception, the showing progress is very important. And how do you show progress? Essentially, there's a theory to it. So we talked about four interval periods. For the instantaneous action, you don't have to show any activity indicator. For an immediate action, 0.5 to 1 second, spinners or very basic progress indicator would do. And for the flow part, 1 to 5 second class D indicator effectively spinner or just a progress bar would do. But if your action is taking anything from 5 to 10 seconds, you need to show a dynamic indicator of which shows how the progress is going on, what is the percentage take. That will make sure that your users are sticking to the action and they are not going away. So yeah, as I said, we 20% faster than your fastest competitor. And don't just focus on full page loading time. The two other important metrics that you should focus on is the first meaningful paint and time to interactive. The first meaningful paint is the time required for a page to display its primary content, and the time to interactive is the time at which your page is ready for taking a user input. There are a lot of useful tools available. Web page test is one of them. It gives you proper rendering the video also, so that you can analyze how your user perceives the website loading. Lighthouse is a tool by Google, which is a screenshot of it tells you what are the it's basically optimized for PWA applications, and the page speed insights gives you basic insights into how your web page performance is. So you can use this tool to constantly monitor your website. You can maybe automate them also. For example, Lighthouse is a command line tool that you can have that run. If you want, whenever a new code is pushed to master or periodically also. So that's it. So what are the ideal response time? For example, in our company, we focus on all of our APIs serving should serve the response within 100 milliseconds. And we are very peculiar about it. We force our developers to rewrite even code if your API is taking anything more than 100 milliseconds. And that's a good estimation if you want to make sure that your website is perceived faster. So do your best to provide feedback in less than 100 milliseconds after initial input. And if you are doing animations on your web page, make sure that you have a 60 frame per second timeline. So each frame of animation should be completed in less than 60 milliseconds. Because your browser needs time to paint the new frame, ideally your code should finish executing before 16 milliseconds. So that should be the numbers which should be looking for. And these numbers are very easy to get at. Chrome has a very good support for profiling and figuring out what is the first millisecond response, and then how many frames per second your website is rendering or animations are happening. So first meaningful paint should be under or about 1.25 seconds. Frankly, it's a very difficult thing to do. In fact, our website take about 2 seconds for first paint. But yeah, that should be your goal, and you should constantly focus your front-end team towards it. In the web page test, there is speed index value which web page test calculates, and ideally that should be under 1,000 on a fast connection. And for mobile, you can take a leeway up to 3 seconds for 3G network and or regular mobile device. Then you should look for making applications which have progressive enhancement in place. So since I didn't know what kind of crowd will be here, so I didn't delve down into this, but this is very interesting. You can serve very small scale application skeleton to start with, and then your data can start appearing. Your features can start appearing based on the mobile device or the browser that a user is using. That will enable your user to have optimal experience in terms of features also and speed also. The next part, I guess most of you guys already should be would have been using, and if you're not, then you should start using is the Accelerator mobile page. And in fact, Facebook recently also announced that they will be supporting AMP for Facebook Instant Articles. And the best part about AMP is there's nothing very differentiating between that AMP is doing. It's just doing very simple things which you anyway should do. It's just there's a guideline. You have those tests available that whether your page is AMP proof or not. But Google provides a CDN also, which helps your delivery faster. And you can build progressive web AMPs also. Okay. So once you have done all of this, then you should consider the micro optimization and progressive booting. There are very small, do's and don'ts when you are doing this. For example, earlier people used to say, in fact, for most pages, still people show loading indicators. Uh, the better thing to do is showing skeleton screens instead of loading indicators. And this we have done in our partner applications and our application, and it has come out really well. The feature has come out really well, and the earlier problem that the users were facing, that they were feeling that responses are very slow. Now they don't complain about that. So what we do is, rather than showing loading indicator that results are loading, we show a skeleton of where your content will be placed. So if there is an image, there is a skeleton there. If there is a title coming in, there is a skeleton of that title there. Then we are not able to optimize the total delivery time. But as I said, if perception is changed, your user will not complain, or they will not feel that your website is slow. You should constantly look for modules and techniques to speed up the initial rendering time, and that can be done by utilizing server-side rendering for Angular JS applications or any React-based applications to get the first meaningful pane very quickly. And if you have done that, then you should also include minimum JavaScript to keep the first time to interaction very close to the first meaningful pane also. So it should not happen that your first meaningful pane happens very fast, but the time to interaction is very slow. That will also kind of the user will feel very frustrated that website is displayed, but I'm not able to interact with it. So you should focus on this web page, what will the user will be trying to do, and if your that particular part of the web page is rendered, how soon it is ready for interaction. Okay, so this is very basic, or actually, but I see constantly that developers or product managers, they forget about this, or don't focus on this. The crucial part about getting caching right is setting HTTP cache properly. Double check the expires, cache control, and max age, etc. If resources are static JavaScript or CSS, etc., you should anyways be caching them indefinitely. You should have a versioning parameter inbuilt into the URL, so that whenever your code changes, your version also changes and URL changes, and effectively the user will get the newest file. For Firefox, there's a new cache support also, immutable cache control, which is designed for fingerprinted static resources to avoid revalidation. So even if your resource is cached, the browser will check whether it's it's still valid. So usually there's a 304 required. So if your cache control is set to immutable, your browser will assume that this resource will never change, and your browser will directly use it. But currently, support is only on Firefox, and all of this basically, so rules that are applicable for me may not be so much applicable to you. You have to really get into the analytics part and understand what kind of browsers your customers are using, and all of these tips are designed that these are bullet points, but you should choose only based on what kind of browsers your websites your users are using. For example, for us, our customers are they have very basic phones. The browser support is very basic. They use even Opera Mini or very old browsers. So few of the things we could not do for our web application. It all depends on what kind of browsers your customers are using. So you should limit third-party libraries and load JavaScript asynchronously, and this will speed up your web page in an order of magnitude of 1 or 2 times. So earlier our home page, for example, was about 1 MB, and we trimmed down all of the third-party libraries that we were using. and started loading them asynchronously. Now our web page is about 500 KB, and all of the third-party resources are loaded asynchronously, so user doesn't feel that there's a loading time involved there. And since then, it has helped us a lot. So there are lots of techniques to do that. iframe is one of them. iframe allows you to have sandbox also. So that will help you from the security point of view as well. So you can sandbox the third party library in a particular iframe sandbox and then use it. Um, there are lots of ways of doing that. Defer and async is also there. If you don't want to use iframe. In practice, you should prefer defer to async, unless and until your users are mostly using IE9 or anything below that. Then check if your images are properly optimized. Since nowadays there's a trend of doing responsive designs, your single design works on multiple monitor sizes. So your images should be served according to that. As far as possible, use responsive images with SRC set size and picture element. So that gives you control on which image size will be loaded on which monitor size, screen size. Then Moz JPEG improves the start rendering time by manipulating scan levels. So every JPEG has a scan level, so it can be loaded progressively. So your user will see that okay, this image is loading, and Moz JPEG allows you to control that scan level, and by using that you can improve the start rendering time. Similarly, you can use for PNG, you can use Bingo and GIF, Lossy GIF, and SVG ONG is the tool for optimizing SVG images. For background images, you can even export photos with blur so that they can still be acceptable, but the size is very small. There's a responsive image breakpoint generator also, which lets you see that okay, if your screen size is mobile, what part of image will your user see? If your screen size is iPad or tablet size, then what part of your image will your user see? And you can design your experience based on that. Okay, web fonts is very debatable topic, and few people like it, few people don't. Personally, I don't like it unless and until there is a specific requirement for it. And in fact, for Asan jobs, earlier we were using Proxima Nova as our font on all of our web pages, and the total size it was consuming even after optimization was about 170 KB. So even if you load it asynchronously or load it afterwards, what happened was 170 KB is a huge size, especially if you are on a mobile network and especially if you are on a 2G, for example. So we completely removed that. It was not serving any purpose for us. If you actually need some kind of web font, it's your call. But then use it judiciously. Start rendering text in fallback right away, and then load font. Start using that font. And web font loader is a very good JavaScript library to do that if you're using third-party host to serve fonts for your web pages. As I said, you might be able to completely get away with locally installed OS, and that's a very good technique because on Mac, for example, you have access to Helvetica New and Kimi Sans and very good fonts, and even on Windows, you have Calibri and very good fonts there also nowadays. So unless and until you are designing a media template for a movie website, actually you don't need web fonts in general. So they only decrease your website performance, and there's a very little benefit that they give us. Okay. So one of the things that you can do is push critical CSS quickly, so that your web page starts rendering as quickly as possible. You can use even HTTP2 to serve to push that critical CSS. If you are planning to do the HTTP2 part, there is a caching part involved. So let's say HTTP2 enables you to push a particular static resource. But what if that static resource is already cached with the user? So HTTP2 doesn't actually specification doesn't have anything which will say that okay, if this visual is cached, then don't push it. So that part you have to implement it yourself, but you know you can do that. So these are the basic things you can do, and actually these are the newer things based on technology trends nowadays. Steve Saunders from Yahoo actually did a lot of research on that, and I'm sure all of you must be aware about these 14 tools. So these are just for your listing down things. I'm sure you guys must be doing all of this anyways. There's nothing very new about this. But yeah, these are very good points to stick when you're designing your experience for your customers. Any questions?
What kind of tools you use to keep checking performance?
So we constantly use web pages. We have ping-dong monitoring set up for ping-dong also gives you that performance report up also. So we have set up that, so it pings our website almost daily, twice a year, and we look at that report to analyze what feature went live today and if it has affected our performance. We also use New Relic to monitor our backend processes, even for example, salary tasks, etc. So that application performance is taken care of.
And font you said you guys loading asynchronously. So
We used to. So yeah, so web font loader is a good script. We used to load font asynchronously, but as I said, for especially in our case, and it's a product call, but for most websites it doesn't really matter.
So what is the measurable difference? Was there any measurable difference?
Yeah, I said 170 KB, and if you're loading your website on 2G, it will difference about 1 or 2 seconds.
And have you observed like point?
Yeah, yeah, we did. So that was the major pain when you load fonts asynchronously. Your page will load. So this image is essentially this only. So you will not see any text until your font loads. Or if you start using system font before, then you will see a flicker when your font loads and browser starts using it. And both of them are not a very good experience for users. So that's why we completely ditched the custom fonts and completely.
Like you spoke about third-party applications. Right? Like let's say you have a marketing website, right? And you have your Google Tag Manager, you have your Facebook scripts, you have your ad manager, you have your remarketing. So all these are always loaded via third-party applications, right? And they load your website like 2 months. So do you have like any out of that? Like
So async behavior is one of them. And in fact, for example, Google Analytics does provide async.
Google Analytics is fine.
For other third-party libraries which you are using, you yourself can basically write a async script so that your that particular library is loaded async, and you use that. As I said, iFrame is also one of the options.
Yeah, but these all are just like scripts, right? They don't come under item.
No,
These are like custom scripts given
Yeah.
by Facebook and like.
So, for example, Facebook Pixel, Facebook Pixel is one of them, and we also use that. But we only load it once all of the pages rendered and uh, all of the inputs are active.
How do you load it afterwards?
So we first of all include it in our footer. Our application make sure that the first crucial part is to get the whole interface right. All the CSS is loaded. All of the HTML is active. As you can see, all links are active. All input boxes are active. And then once your page load is done, then you start loading them.
But like most of the places they specify that you have to keep these scripts in the head tag.
Yeah, so Google Analytics doesn't specify that. And in fact, if you don't put it in head, you might lose out on analytics where user starts loading the page, but page load is not complete, but they go away, and Google Analytics will not register that bounce rate.
Yeah.
So that's actually a problem. And So that's why in fact we use Google Analytics in head and all of our other scripts are loaded in folder.
Okay, okay.
So yeah, so essentially it is basically you have to find the best of all the parts now. You want to give the best feature also, speed also, and at the same time you want to see all that analytics also.
Yeah, that's good.
You have to make the best of all of it. Okay, so next part will be taken care by Harsh. We'll talk about security and how front end can implement few changes so that your web application is secure. Of course, security is a very broad topic, and from encryption to how your data is stored and even how your infrastructure is managed. There are a lot of things which comes under security. But today we'll only talk about security from a front end point of view.
Hi guys, my name is Harsh. I work at Assamdog and I've been working on JavaScript for like past 3 years. So yeah, so we'll talk about the security aspects of the browser and the nitty-gritties that can be taken care of in the front end itself, so that not a lot of backend stuff involving over here, only to focus on the front end part. Okay, so we'll start with the very basic attacks like the cross-site scripting attacks that I think you all must know what those are. And like since there was an expectation mismatch between the kind of audience that we were expecting and the delivery that we made. So let's stick to this. Yeah. So this is basically
As I mentioned, stick to your karma. Don't worry about others.
yeah. So yeah, this basically happens when you get some code injected on your client side, and like the most commonly used scripts are JavaScript for that, and nobody uses Flash anymore. So yeah, and there are two types of it: the reflected one and the persistent one. So we'll get into how it works, and then I'll differentiate between the two parts, that was the reflected and the persistent one. So basically, how it works is that you have your victim out there sitting using its website, and then there is this attacker who would want to, let's say, make a request or load some script on their browser. So one of the ways could be like, let's say for example, you search in Google hello world, and the next page that redirects to has the word hello world into the URL bar itself, right? And so if the user inputs are not being made HTML safe, so someone could also include a script tag over there and say like load a script from some evil site, right? And as soon as your page will load, the script will also load and kickstart automatically, doing the wrong things that the attacker want to do. And I could simply put that link, shorten the URL, and send it to you as an email or a thing, and say, oh, like cute puppies over here, and you might go and click it and have it there. So your website can be used this way to have an XSS attached. Then you have it. But this is a reflected one. So a persistent attack is something where the attacker is successfully able to infect your complete website. For example, if the attacker is able to store the script into your comment section in your DB, so anyone who loads that page will now get the script, and it will have a greater impact area, and it will be there for a longer time till you manually go and remove it. So for example, the blue one is your victim, and the red one is your attacker. There, and so the step one is like your victim is loading up web page, and yeah. So the attacker injects a payload. For example, I sent you a link saying cute puppies here, and it contains the script tag result, which contains my evil code. So that's how we load the page there. And yeah, when you request the page, you'll get the script loaded onto your browser. And now, since the script is loaded on my browser, it will execute and do what I intended it to do. Cool. And yeah, that's how. So for example, I can steal your cookie and email it to me, and then I can impersonate you on the same website if I am able to steal your cookie. Yeah. So in this case, the cookie is stolen basically when the attacker put the script of stealing the cookie there. Yeah. So how can you protect it as a web application? So there are headers to it, which has three options basically. So these headers are the options are XSS protection 0, 1, and 1 with a mode block. So basically, the 0 thing simply ask the browser to not worry about anything, and like everything is taken care by the application itself. So this is most prone to the attack. Okay, and protection level 1, this basically is a default setting on all the browsers there. And this basically tells browser to intelligently look for script tags in places that it should not have, like in between some image that you have written, that's being loaded. And so browser, this could be only as smart as the browser can be. So if the browser is able to read all that stuff, and then it filters out that scripts which are not expected to be in those places, and it will load your page anyway. While this one is the most recommended one, that says that simply do not load the page if you find any such scripts going around. So if there is an image loading on your page, but the image contains some script tags, then the image will not load at all. So these are the settings that you should be using as per your needs, like what is the behavior expected there. Okay. Now the next part is CSP. So CSP is basically content security policy, and that means that you define you define where your content can come from. So, for example, I can, in a very granular manner, I can define that we only load my JavaScript from only this XCDN or subdomain.mywebsite.com only. Let's say I have a dedicated subdomain to only load my assets like all the images and JS and CSS, and so this could be safe. So that even if an XSS vulnerability is there, so even if someone is able to inject a script saying that load X file from hacker.com, but then this policy will not allow the browser to load that file in the first place, and even if you have an XSS vulnerability, it cannot damage your user there. So this basically defines that what are the places that are safe to load content from for your website. Okay. So, for example, this is and this can also be you can also check it against a hash or a signature. So when you set it, when you write it in your HTML, like load the script, you can also write that the integrity sum should be this. And once the browser loads it, the browser will calculate the integrity sum and match it to this value. And if they both match, then only the browser will use the script, or the browser will simply discard this. So this is also security. This is also a way you can define the things. And yeah, you can always use this headers like the content security policy and the directive and the text, more directives. So we'll see a few examples over here. So this is one example where you're using saying the default source self. So it basically means only load the resources from the same domain itself. The same domain basically also includes all the subdomains. A.asandra.com, B.asandra.com, it's all fine as long as the domain name is same. And yeah, so the next one is the connect source. The connect source is basically restricts the URL which can be loaded using script interfaces. So it is all right if you click on a button and that loads something, but your script inherently cannot invoke something to make a call to some different library out there. So that is define that what are the limitations that JavaScript could automatically behave. So this also helps preventing in some major vulnerabilities because major attacks. Because if someone loads a script, injects a script, then they cannot take advantage of it because this limits the reach of the domain where they can load the content from, right? And then there is, as you can see below, there's also a script tag. So you can also simply say, okay, load my script from this domain only. So that's how you can have a dedicated domain or a CDN, for example, that you load the resources from. And yeah. So the moving on, the next would be Xframe options. So Xframes are basic. So they why do we need this? This is a very small thing, but so clickjacking is a thing. So we all know that there is a innocent looking game where you are playing ping pong or you are hitting balloons and getting balloons, but there could be an invisible iframe that is simply redirecting your clicks to retweet the tweets or maybe following someone on Facebook or maybe liking someone's picture, or even in worst case scenario they can even get control of your microphones and webcams. So that could be done. For example, they show you the screen that flash permission is required, and just above it is a invisible iframe which contains the settings box for the same Flash player, which can get limited access to that application and compromise your microphones and cameras. So this is an old technique that bait the people that they wanted to spy upon. Cool. So how do you stop it? So you simply add the headers options like extreme options. So you simply deny them. So deny simply like no one can put your page in an iframe. If anyone tries to do that, the browser will not work. It simply will not work. And if you say same origin, so only the same origin people can put your web page in an iframe, right? Or you can also define some origins, like allow from this X domain and like it's a very self-explanatory. You can use this.
Uh, what's your backend you guys using? Messenger? What?
Django.
Django. I know in Node we have something called helmet where you put that in there and everything gets solved. Is something similar there?
So Django has this option as a setting variable. So you can simply use that.
Use all this what you mentioned, access and all.
CSP for CSP you have to use a third-party library, but for example for XSS and extreme options, there is a setting of.
You can also set it on your like Apache or even anything that you're using there.
Yeah, but we are in Node this was this whole package just put helmet yeah, just everything is just stuff.
Yeah. So now this is one more thing called X content type options. So we all know that whatever web page or whatever web content that we load has a tag called content type. So it was required for servers to set the content type for whatever content they are serving on the application. But as we know that web has always been broken and many people did not used to do that. So browsers eventually became smart and they decided to be really helpful. So they invented something called mind sniffing, or mind sniffing is the wrong term. It's basically it's basically a browser feature which examines the content and determines what it looks like or what it is and does the most obvious thing. So even if the content type is set to text HTML, but it looks like a JPEG, the browser will show a JPEG. If it looks like a GIF, the browser will play the GIF. If it looks like a binary file, it will download it simply. Even if the content is set to something, even the content type says like it's an HTML or it's not, it's a PNG or it's something else, but the browser will not obey it. So then there came this option which tells the browser to like override it simply its default functionalities and do what they're saying to do. So if you simply set this content type options to no sniff, the browser will no longer look for, no longer use its own creativity to determine what kind of data it is. It will simply do whatever you say. And why do we need it? Because we must be thinking like, okay, if it's a JPEG and browser is showing me a JPEG, then what's wrong in that? But for example, if you're having a photo sharing app and a file that looks like a JPEG or an image is an HTML. Content type is actually an HTML. It's an HTML with a script, and so there you have it. There you have it. Accesses on your application right there, because the browser will simply show it and load whatever it is. But if it says that it's an HTML, then it will not happen like that. Right. Cookies. Now we almost everyone knows what cookies are and they have been using it day in day out. So I'll be just focusing on the fine print that those are there in the cookies and which I think a lot of people might not use it there. So cookies have a lot of options to make them safe. So one of those is secure. So if you add an option to your cookie to secure, it will be only delivered over HTTPS or it will be only altered over HTTPS. HTTP cannot do that. And then there's an option called HTTP only, which basically restricts your JavaScript to accessing your cookie. So this option is good if you are using your cookies only for authentication or only for server-side authentication. So then even your application's JavaScript need not access the cookie. And so even if the accesses or some script has migrated into your user's page, it will be harmless because it won't be able to use the cookie and won't be able to steal the cookie or read it in the first place. Right. The new one is the same site, which is an experimental thing, and it helps us defend against the CSRF attack that we'll see later. So the same site basically says that only send the cookie with the request if it is to the same origin. So if I send a cookie on azandrop.com and if I make a request to google.com, the cookie will not be sent along with the request. So this prevents that. So so let's say someone manages to inject a script there, but still they won't be able to make a request to their own domain and get the cookie there so that they can impersonate the user who is logged in already. Yeah, so this is how you set the cookie, like the simple cookie, and it expires on the expiry date. And secure and HTTP only are the two ones that everyone should be using, everyone must be using. Yeah, and so basically, if you are using cookies for other than authentication, then you should have multiple cookies, and the authentication cookie should be an HTTP only cookie, so that it is relatively secure. Yeah. So now this is CSRF cross-site request forgery. So this basically means that a hacker or an attacker wants the victim to perform some action on a portal which is already authenticated, already logged in. So, for example, if you're logged into your bank account, in a net banking account, and I want you to transfer like $1,000 to me, so you're already logged in there, you already have the privileges to do that, but you only don't have the intent to do that. And while I force you to do that, so that's basically SRF in a nutshell. So this is how it typically goes. So there's a victim and they log into the bank account. They will set the cookie there because the session login cookie, and then there will be a script which will, for example, hit to my server because I have injected a script there. And then when the request is made, when the third request is made, I will get access of your cookie. So if the same site uh, attribute has been used in the cookie will not be sent to the third request, and so then I won't be able to get the access here. So that's how the same site helps doing this attack. But for example, let's say capture your cookie in some way, and then now I have your authentication details. Now I can simply make a request to the bank site with your cookie and get the money that I want. Right. So this is how it typically works. And one of the other ways is also basically I know it's a form submit. So if I know all the parameters of the form and if I know what it looks like, I can simply inject a script that runs on your browser on behalf of you to do that, and then it will be done. So even before you know, this will be executed, and yeah, so that's a attack right there. Cool. So how do we stop it? So we stop it. So the state of the art or like the most common one are synchronizer tokens. So synchronizer tokens are basically CSRF tokens as we call them. So what they are used is they are added as hidden fields in your forms or in the URL for any state changing operation. So you define that these are the crucial operations and these will alter a state, for example, transferring money or like booking a ticket or things like that. So when you load that form, you also load a hidden field, hidden input field with that token. And once the form is submitted, on the back end you check if the form contains the hidden element which was intended and generated for this particular action. If it matches, then only you authenticate the action, or else you do not, you simply reject the request. So this also helps there because if someone manages to get in, but they won't have the token because they cannot read the cookies, and cookies are HTTP only. So this way you can prevent them CSR attack. Cool. And yeah, so token has to be cryptographically secure and a large random value. It cannot be simply typed. So that will not work. Yeah, and some other ways if you do not want to have a server-side hassle of maintaining that session token. So something is called double submit cookie. So in that you basically send out the form element and you also send out the same value in your cookie. And when the request comes back to the server, you match both the elements, the cookie and the form element, and you see, hey, yeah, this is perfect, this is right. And the same side cookie attribute, you can secure your cookies by using the same side cookie attribute, or you can have a user interaction. So basically OTPs that we see or captchas that we see, so that it intends the user to action upon it again, so that we know it's not unintentional. Right? Yeah. Do that into all.
Is that? Any questions
Any questions?
for Harish and Verma?
In case of login page, we have then OTP request to be sent to an SMS gateway. I think that's an exact form and that will be cost. So in that case, I need to write it.
Or we can, first of all, I think that should be done from the backend. So you should not set OTP from your front end anyways. The backend should send, that's a much secure way of doing it. So instead of relying on cost.
Just one more double check.
Yeah. So the double submit cookies are basically so you basically enter a CSR token into your HTML form that there is, and you also set the same value in a cookie, which is your secure cookie if it's an HTTPS connection and an HTTP only signed cookie. So that the JavaScript, even your own JavaScript on the page is unable to access the cookie. And when the request is again made to your server, and you also have the same site attribute set to the cookie will again you'll again get the cookie in the request. You'll also get the form You will have the same token in the form and in the cookie. You match them, and you define that the source was correct and the source was authentic.
And then, cheers. Thank you. Yeah, and